Hello, this is Mr. Tupas, and today we're going to talk about adding and subtracting inequalities. Now, the good news is adding and subtracting inequalities is pretty much the same thing as adding and subtracting equations, except we're dealing with inequalities. Example, I have here 2 plus x equals 4. This is an equation. Sum of 2 plus x is equals to 4. Now, again, in solving equations, the goal does not change. Our goal is to isolate x, make x all by itself. How do you do this? First thing is we need to get rid of the 2 here. How do we get rid of that? We subtract 2. Okay? Now, subtracting 2 with a positive 2 will equal to a 0. And that way we got rid of the 2 over here and make x all by itself. Now we don't need to write 0. Now what I do to one side of the equation, I have to do to the other side of the equation. So if I subtracted 2 here, I have to subtract 2 here also. Now, next step, bring the variable over here equals 4 minus negative 2 or 4 plus negative 2. When you combine a positive and a negative number, you subtract it and then you take the bigger number sign. So what I will have here is a positive 2. And that is how an equation works. Now, in an inequality, instead of having an equation, we have what we call the inequality symbols. And what are those? We have the greater than, we have the less than symbol, we have the greater than or equal symbol, and we have the less than or equal symbol, and last but not the least, the not equal symbol. So instead of this equal symbol, we have either one of the 5 inequality symbol. So for now, let's change this equation symbol into a greater than symbol. Now we have here an inequality equation. Okay. We have 2 plus x is greater than 4. How do we solve this? Again, same rules as an equation. We have to isolate x. We have to make x all by itself. So in order to do that, the same steps. We add negative 2 here, and negative 2 plus a positive 2, when you combine them together, you get what you call a 0 pair. Again, that's a 0 pair. So this will become 0. We don't need to write 0 anymore. We bring down the variable x. We bring down the inequality, which is a greater than symbol. And what I do to one side of the equation, I have to do to the other side of an equation. So if I added a negative 2 here, I have to put a negative 2 over here. So a negative 2 and a positive 4, when you combine them together, you subtract them and get the bigger number sign. So what I will get is a positive 2. And there you go. This is the answer to our inequality. The solutions for an inequality is x is greater than 2, which means every value of x has to be greater than 2. Now, how do I graph this? Very simple. Example, I have the graph over here. I have 0 over here. I have negative 1, negative 1, negative, positive 1, 2, 3, 4, and so on and so forth. I encircle number 2. Again, this will be an open circle because this is a greater than symbol. And the values of x has to be greater than 2, which means the graph or the line goes in this direction and you put an arrow over there. Now, how do you check if your arrow or the direction of your arrow is correct? Well, I will first substitute the numbers over here with x. For example, 3. If I substitute 3 with x, is 3 greater than 2? Yes, the answer is correct. How about 4? If I substitute 4, is 4 greater than 2? Yes, the answer is correct. So yes, the graph goes there. How about I substitute -1? Is -1 greater than 2? Of course not. That is how we can be sure that the graph goes here, because if I substitute the values that I have here with x, it has to be greater than 2. Okay, here's another example. This time we're going to use addition to solve for the inequality. I have here the equation x minus 5 is greater than 8. Okay. Take 2. Okay, up next we are going to use addition to solve for the inequality. What I have here is x minus 5 is less than or equal to 8. Now, to solve for the inequality, still it is the same. We have to isolate x. We have to make x all by itself. So, I have to get rid of -5. I get rid of -5 by adding +5. Now, if I add +5, what happens is it becomes a zero pair, meaning I subtract it and I will have 0. We don't have to write the 0 anymore. So I just cancel this out. I bring down the variable x over here. I bring down the inequality, which is a less than or equal to. And again, as in any equation, what I do to one side of the equation, if I did a +5 here, I have to add a +5 here. So there you go. 8 plus 5, what I get is 13. And our final answer for this inequality is x is less than or equal to 13, which means the values of x has to be less than or equal to 13. How do I graph this? Very simple. If I have a graph over here and I have probably 0 over here, I have 13 over here. Okay, I will put a closed circle. I need to shade this properly. Closed circle because this is a less than or equal to, and that is a closed circle, meaning that 13 is part of the solution. And then the arrow goes to, if x is less than 13, and the arrow has to go to this side. Okay, this side. And then I put an arrow over there, and that's it. Now, how do I know if the equation is correct? Remember, assuming that 7 is over here, and this is 15. Alright? If I substitute 7 in this equation, if I substitute 7 to x, okay, is 7 less than 13? Yes, that is correct. How about if I put 15, which is on this side of the equation? Is 15 less than 13? Of course not. So this is wrong, and that's why we know that the equation, that the graph will go this way.